This is Mark, and welcome to another Tech for Teachers. In the last video, we learned to insert some images into our document, and today we are going to take that one step further by drawing an image using a little bit of code. We are going to be working in one of our asset folders called the tkz image folder. So there was a reason why I called one of these folders tkz. And this is the image we're going to replicate today. So as it is pixelated. And what I want to do is transform this into a scalable vector drawing. And that will be a PDF in this case. Now we're going to need to create a new document here, and we're going to just call this 0000.tex, and it is a tex file. And our tex file is going to need a document class. And for this one, we are going to be using the standalone class. And this is an incredibly powerful package because it allows you to write a little bit of code and display that as a preview or directly to a PDF without it being formatted in any special way. Okay, I can't do this anymore. I just started to write an environment here, and I have to go into the settings and toggle the autocomplete to on. I believe this is on by default, but in the initial videos, I had toggled this to off so that you wouldn't see the code completion that you see now, and so it wouldn't complete the environments automatically. But the time has come to turn on autocomplete. And notice when I started to type in the command begin, it gave me a list of possible environments, and then it closed the environment for us automatically, saving us a lot of time. So the package that we're going to be using today is called tkz-euclid. In fact, I should call this tkz-euclid with an E. So this actually isn't tkz, a drawing package for LaTeX. It is using the tkz package to make drawing geometric objects a little bit easier. Now we still have access to the tkz drawing package, and in fact we are going to draw in the same tkz picture environment that we would draw a standard tkz image. We can start defining some points of our triangle using the tkz-defPoint command that is case sensitive, followed by the coordinates of that point as an ordered pair. I'm using 0, 0, and then a label for the point. I'm going to call this point A. We are going to then define a second point, once again using the tkz-defPoint case-sensitive command. I won't say case-sensitive again. And then once again, we're going to need to provide it a set of coordinates, and I'm going to use 5, 0 this time, once again expressed as an ordered pair. And then I'm going to label this point C. And we can see on our diagram, I have a point A and a point C with a set of coordinates each. Now that we've defined 2 points, we have enough information to define a triangle, and we're going to do so using the tkz-defTriangle command. Now this command has a few different options for different triangles, and for our purposes we are going to use a gold triangle, and we're going to define this triangle based on the 2 points we defined, A and C. Now what's really cool is we can actually get that third point B using the tkz-getPoint command and labeling it B. So we are actually going to be able to calculate the value of the coordinates of B without having to state them explicitly. Now there are other options for triangles such as Pythagorean and school triangles, and that's all in the documentation. But for us, we have 3 vertices now, so that's enough to draw our triangle using the tkz-drawPolygon command. And you'll notice here when we compile the document, for the first time we get something in the preview pane. We have a triangle. That's really exciting. But before we get too excited, we have a little bit more work to do, and we are going to continue by labeling the vertices of this triangle. To do this, we are going to use the tkz-labelPoints command, and I'm going to tell it which point I'd like to label, and that's point A. And when I compile this, it will label the point A with its name. Now, it doesn't match our reference diagram, so I'm just going to provide this tkz-label-points command with the option of left, and you'll see that this will now place our label to the left of the actual point that we've defined as 0, 0. Now we are going to label point C, and I'm going to leave the option blank for a second, and I just want to see where it's automatically going to place the label. And obviously this one's going to need some adjustment, so I provide it the right justification option, and now that's a little bit closer to our reference diagram. The last point that we are going to label is point B, once again leaving the option blank and compiling it to see where it'll place it, and that's obviously not a good placement, so we're going to change the option to above. And let's go back to our reference diagram where we see we have two edges of our triangle that need labels. Now to do this, we are going to make use of the tkz label segment command. So we're actually labeling segments, and in this case, we are going to label the segment AC. So it has a starting point and an end point, which are A and C. So the tkz label segment command has a starting point and end point expressed as an ordered pair, and then inside the curly braces we are going to provide the actual label, and in this case I'm going to use the label of 8, and I've done that in inline math mode for tech. Now the 8 should be below the segment, so to do this we're going to provide an option to the tkz label segment command, and we're going to justify that below, and that's looking much better. We have a second segment, so tkz label segment, and this is going to be the segment defined by the points A and B, so starting point, end point, expressed as an ordered pair, and we are going to give it the label, in this case 6, and we'll just see how it is positioned, and that works out okay, so we can go ahead and delete the option to the tkz label segment command. We have one last thing to include in our diagram, and that is the label that says diagram not to scale. So to do this, we are going to use the tkz text command and then provide the coordinates of where the text should appear, and then in the curly brackets we are going to include the text that we want to see, and in this case I am going to boldface that text that says diagram not to scale. Now that isn't quite where I want it positioned, so I can simply play with the coordinates a little until I get something that looks very similar to our reference diagram. Now that we have an image, we want to download this PDF to our computer, and then we are going to upload this PDF to our tkz image folder. Unfortunately, it doesn't do this automatically, but we can easily just download and then re-upload. I'm going to change the name of this file so it matches the text file that was used to generate it, and then we can go into our main document and insert this image. So let's find a place for it. Maybe in the research section will be good. And so let's go and include a figure environment here. Now notice that all of this was done automatically for us, and I just need to give it the graphic name, a caption, and then a label. Now since we have a predefined path where to look for these images, we just need to provide the image name. So now when I go ahead and compile this, we should see our figure. Oops, it placed it at the top, but we know how to fix that. Now we can just give the figure the option H to place it here in the research section. And that's enough for me to call this one done.